All right, I'm back, and now we want to talk about mechanical energy. And remember that there were two kinds of mechanical energy. So you had potential energy, and then you had kinetic energy. So let's first talk about what potential energy is. So it's going to be, I am going to abbreviate it by saying energy, and then I'll put a P next to it. So that stands for potential energy. Now, in some textbooks, they might like to use the letter U to stand for potential energy. And then in your textbook, in the Hewitt textbook, he likes to use PE, so potential energy. But I'm going to try to use the letter E to represent any kind of energy. So E, and then I put a subscript P to indicate that it's potential energy. So what is it? So it's going to be energy of position. So it's going to depend on distance. So as the distance increases, so is the potential energy of the system. So I've got 4 examples of potential energy listed there. So let's look at the first picture, which if you blow it up, you'll notice it's a dam. So how does a dam work? So you've got the river that is down here. Okay, then you build your dam, and then what's the purpose of the dam? What it's going to do is it's going to store water behind the dam. So that water used to be down in the valley in the river, but then when you dam it up, do you see that it's going to be raising that water on the other side of the dam? It's giving potential energy to the water by raising it. Okay, then if you want to get the energy back out, you let it go. So that's what the spill gates are for on a dam. So it allows the water to fall, and as it's falling, it gives off energy. So I just want you to see this or hear it, because imagine that I take this pen and I lift it this high and I let it go. Did you hear that sound it made? Okay, now I'm going to lift it so it's higher. Did you notice that it gave off more energy? In what form? Well, sound waves. So did you hear it? Okay, it also made the table a little bit warmer. So it caused the atoms in the table to vibrate, and so that also took in some of that energy. So this is potential energy. It has the potential to do something. So as long as it's in my hand, it's not doing anything. But it still has energy. Now, where did the energy come from? So when I lifted it up to here, energy came out of my mighty muscles here in order to lift it. Okay, now it's up here now. It has stored that energy in the form of potential energy, and then in order to get that energy back out, you just release it. Now, the formula for that is given by the formula underneath there. So we're going to say that potential energy is going to be equal to M. Now, what is M? That's going to be the mass of the object in kilograms. Remember, that's the official metric unit for mass, the kilogram. All right, now you should recognize the letter G. So that was called the acceleration due to gravity. And G was equal to 9.8 meters per second squared. So it's gravity. So potential energy depends on gravity. And then H stands for height. So that's going to be how high did you lift the object. So this brings up a whole bunch of conceptual questions. So conceptual question number 1. See if you can answer these conceptual questions. Ping pong ball, what color is it? It's red. Can't you see that? All right. Then over here, you've got the bowling ball. What color is it? I don't know. Blue. So you got the little ping pong ball. You got the big bowling ball. All right. And you're going to lift them both up 1 meter. You're going to drop them on your toe. Don't do it. Don't sue me. Don't drop a bowling ball on your toe. I'm telling you, don't do it. All right. But if you did, which one's going to hurt more? It's going to be the bowling ball because it has more mass. So it has more mass, so therefore it's going to have more energy, which it's going to impart to your foot, and it's going to hurt a lot. So that when you got two things, the one that has more mass is going to have more energy if they're at the same height. Okay, question number 2. All right, so now let's say that you've got a ball. I won't even specify what kind of ball it is, but you've got a ball and you're going to raise it 1 meter up, drop it on your foot. I don't know why I'm so violent, but anyway. Take the other ball, raise it up 2 meters, and drop it on your foot. Which one's going to hurt more? Okay, it's going to be the one that you lifted higher because you gave it more H, so it has more potential energy. Okay, third example. You got 2 bowling balls. One bowling ball, you drop from a height of 1 meter onto the floor, and then you take the other bowling ball to the moon, and you drop it on the floor. What's gonna happen? Same height, same mass, because they're both bowling balls, but different planets. So what do you think that's going to do to G? So on Earth, it's like 9.8, but then if you go to the moon, it turns out to be around 2. There's less gravity on the moon, so therefore you're going to have less potential energy on the moon. So it depends on those 3 letters. Okay, now let's talk about the second picture. So the second picture is what? Okay, that's a bow and arrow. So there's another kind of potential energy called spring potential energy. So if you take that bow and you pull it back a certain distance, it's going to have a certain energy. And then if you pull it back further, then it's got more energy because it's got a larger distance. Now, the formula for spring potential energy, we're not going to do it. But it's different than that formula there for gravitational potential energy. Spring potential energy is related to atoms because the atoms are stuck together because of electricity, and then when you pull the bow back, do you see that you're stretching, you're pulling those atoms further apart, and they don't remember that they're being held together by electricity, so that the spring potential energy is related to the electrical energy inside of atoms. Then what do you think that the third one, that's a picture of 2 molecules, and so in chemistry they study how atoms hold on to each other to make molecules, and then how one molecule can change chemically into another molecule, or maybe it breaks apart into 2 things. So the thing that's holding it together is electricity, so this would be electrical potential energy. And then what do you think is the last picture there? Okay, I'll give you a clue. You can't hardly read it, but one of those little sphere things is a proton, and then the other one's a neutron. So what's the object that has a whole bunch of protons and neutrons inside of it? Okay, that's going to be the nucleus. So what kind of energy do you think we're talking about? Nuclear potential energy. There's going to be a force that's holding the protons and neutrons together. And then when you can disrupt that, then that gives off energy. And so that's going to be nuclear energy. And we'll talk about that in a different lesson. So I just wanted to point out to you that there's more than one kind of potential energy, but they all depend on distance. And so the one that you need to know about is going to be gravitational potential energy. So here is our conceptual type question where you have object A is a certain height off the floor, but object B is going to be 5 times higher off the floor. Which one of them has more energy and how much more energy? So if object B is 5 times higher, it's going to have 5 times the amount of energy. So if you multiply one side of the equation by 5 times h, you got to multiply the other side of the equation by 5. So it's going to have 5 times the potential energy. Okay, but I also want you to be able to do math questions. So how much potential energy, or how much energy does it take to raise a 2 kilogram object 3 meters off the floor? So write down what you're given. The 2 kilograms is a unit of mass, so that's m. The 3 meters is a unit of distance, so we're going to say it's h for height, and then we're looking for the energy. So what's the only formula that we've got that has E, H, and M in it? Well, that's the one we just did. So potential energy. So we plug in our numbers and we get the amount of energy, and then we need to put the unit on the end of it. And the official metric unit for energy is going to be J for joule. So that was potential energy. So let's take a break, and when we come back, we will talk about kinetic energy.